In this tutorial, I will assign ports lump port to transmission line 1 and to transmission line 2. Then I will finally give it to excitation. First of all, delete box and zoom it. Change axis because I am working on these axes. These axes can be Z axis and X axis. Change it into Z axis plane. Put these information and click on OK. Here it is. Give it to a name port 1. It is fine attached with when you are going to design an lump port or any port, you must keep in mind from one edge it must connect it with design, and second edge must be connected with ground plane. Here you can see that this is our design, the one of edge is connected with it and other with ground plane, and it is slightly above from design and slightly below from ground plane. Because of good matching and good feeding, I have did this. You always make such kind of port. You can also change the length of this port to make it little above the design and little below the ground. That will create some changes in your results. You can monitor these results. Where the best matching comes out, you will go for their design. Similarly, I am going to create port 2. Put this detail. Click on OK. Similarly, this port is also slightly above from the design and slightly below from ground plane. Click on port 1 and go to HFSS. and given to excitation as a lumped port. You can change the resistance, but we have transmission lines whose resistance is 50 ohm. Now I am going for 50 ohm. Next, here you click to a new line. Click here. It's defined. When here comes defined, it means your port is properly defined. If another than defined comes out, you will do undo and go again for excitation. Click on next, finish. From here you can see that excitation, port 1. Similarly for zoom position, you can go for it. Now I am going to assign lump port to port 2. Click on port 2. Go to HFSS. Assign lump port. Similarly, you must check we have made it in a cylinder. The material is also assigned to it. Substrate, we also assigned a material to it. Similarly, lump port, we gave an excitation to these two ports. And ground and design is perfect. Here you can see that the boundaries, the perfect is assigned to design. This is substrate and this is design. Now I am going to create radiation box. First of all, go and change axis from XY axis. put these dimensions: position, x-axis, y-axis and z-axis, so that the radiation box must cover all our design, substrate and ground. Design, substrate, ground must be inside of radiation box and does not touch from any side. Click on OK. After doing this, you must check it does not going to be outside of any side. You can see the perfect. On this side also perfect. This side perfect, and this side also perfect. Here you can see that it is lies. Our design lies inside this radiation box. Now I am going to assign these radiation box an air, because our antennas or filter always working in air. Here already is vacuum. This is not for vacuum, because we are going to study the radiation of this filter inside this box. How the radiations will work. Now for that purpose I am going to change the environment of radiation box from vacuum to air. Because vacuum and air, there is a big difference. In air contains some property, some kind of relative permittivity, and also this factor mass density and other features. Click on OK. Here you can see that. Give it to a name. Radiation box, the red box. Now I am going to give it an excitation card. Now I am going to give this radiation box as boundary called radiation. Click on radiation box. Go to boundaries and assign radiation. Let's click on OK. Here you can check. Similarly, this perfect is assigned to a, and finally you must keep in mind, check these points while before going to give it an analysis setup. Here you can see that your design is perfect, your boundaries and excitation is perfect, all other is perfect, but still I have not given to it an analysis setup. Before giving an analysis setup, you must keep in mind, first look at the design, where design. This is our design. We have assigned it to a perfect E. It's okay. Ground assigned perfect E. Port 2 give then a lump port. And substrate material is Rogers. Cylinder material is copper. Radiation box material is air. And similarly, you can check it from here. Excitation to 2 ports is okay. Boundaries perfect T2 design, perfect T2, ground, radiation to radiation box. After doing all these, I will go for analysis setup. In next tutorial, we will discuss how to add analysis setup, how to add frequency, and then finally we will add sweep, and then we will go for results.